Hello everyone, good morning, welcome. Thank you for joining us for this morning's talk about mastering Spring Boot's Actuator. My name's Andy Wilkinson. I work for Pivotal, where I'm a member of the Spring Boot team.
Hi everyone, my name is Madhura Bhave, and I also work for Pivotal on the Spring Boot team with Andy. Thank you all for joining, and hope you're having a good conference so far.
All right, so we thought we'd just start by trying to maybe fill in a blank for some of you about, why is Spring Boot's Actuator called Actuator? I didn't know. How many of you knew what an actuator was before you'd heard of Spring Boot Actuator? A few hands. Okay, so an actuator is actually a physical device that's used, so it's a mechanical device for moving or controlling something. And we kind of see Spring Boot's Actuator as being a bit like that. It's a device for basically controlling your Spring Boot applications. So to start you on the journey towards mastering Spring Boot's Actuator, we thought the best way to get going was to show you some of the things that are new in the actuator in Spring Boot 2.0 and in Spring Boot 2.1, which we just released M4 earlier this week, and that will be going final next month.
Okay, and let's just jump straight into the code to see some of the new features in the actuator in 2.0. So what we have here is a very simple Spring Boot application. You can see you're familiar at Spring Boot application annotation, and this is the main application class. The application.properties file, it's empty right now, but we are going to go ahead and show you some configuration options for your actuator endpoints. Just a quick look at the POM. We are using Spring Boot 2.1 M4, so we just released the 4th milestone this week for the upcoming 2.1 release. The web starter will start your application up on Tomcat by default, and we have the starter actuator, which will give you the actuator endpoints. DevTools is just so that when we add the properties, the application will trigger a restart and automatically. So let's go ahead and fire up this application. If we take a quick look at the logs here, you can see that that says it's exposing 2 endpoints beneath base path /actuator. So one of the changes that we made in Spring Boot 2 was by default, HTTP actuators are not enabled except for the health and the info actuators. And we realized that a lot of times your actuators contain potentially sensitive information, so we didn't want you to expose sensitive information accidentally to anybody over the internet. And health and info by default don't contain any additional details, so we've exposed them out of the box. It's a little bit different for the Jmx actuators because Jmx is inherently more secure than HTTP, because by default you can only access the mbeans if you're on the same machine. You will see more actuators out of the box if you're using Jmx. So let's fire up JConsole and connect to our application.
So you'll see here within the Jmx console, you can see there are a bunch of endpoints listed. Many more, as Madhura explained, than the 2 that you get exposed over HTTP by default because of Jmx inherently being more secure. A lot of the names that you're seeing here should be familiar to you from Spring Boot 1.5, so the Beans endpoint, for example. But there are also some new endpoints in there. Scheduled task endpoint is new in Spring Boot 2.0, gives you an insight into anything you set up with Spring Framework scheduling support. You can see what's going on in there. We have a bit more detail about that later on in the presentation. There's also a caches endpoint, which again is new in the Spring Boot 2 line. And we've also reworked a few of the endpoints. For example, the HTTP trace endpoint has been renamed. That was the trace endpoint in Spring Boot 1.5. Renamed to HTTP trace to better reflect the fact that it is focused on tracing of HTTP requests rather than kind of broader tracing across the whole of your application.
There are a few more that you don't see in this list. For example, the sessions endpoint, because our application doesn't have Spring Session on the class path.
Which is just Spring Boot standard auto configuration. So if you drop Spring Session on there, the actuator endpoint for that will be automatically enabled for you. We've also got, you can, so the kind of that list shown there in the in JConsole, the MBeans available via Jmx. There's also kind of an HTTP equivalent for that, where you can get a list of all of the information about the endpoints. Do you want to?
Yeah, and before that, I just wanted to point out that in Spring Boot 2, we've moved all the actuators under the actuator base path. So we realized that in Spring Boot 1.5, we would place all the actuators at the root path by default. You could configure it, but we started noticing that sometimes in your application, you might want to use the info path for your own request mapping, or maybe the env path at the root of your application for your own request mappings. So now we've grouped them under the actuator base path. But we still give you a configuration option to configure the base path. So you can put in whatever you want your actuators to be under using the management.endpoints.web.basepath property. If you want to go back to the default 1.5 behavior, you can just use / and the actuators will be available at the root of the application. But for now, we're just going to leave them under actuator. And going back to what Andy was saying, we do have all the actuators available over HTTP as well. And the way we can expose them over HTTP is using the management.endpoints.web.exposure.include flag. So you can specify a comma-separated list of endpoints, or if you want to expose all of them over HTTP, you can use the star.
And there's a key difference here. There's two concepts to think about when you want to look at your configuration and know which endpoints will be available remotely. So there's a concept of an endpoint being enabled, and if an endpoint is enabled, then that means that the beans will be created for it. But you then also have to expose that endpoint to make it accessible externally. So you can expose it over the web, over HTTP, or you can expose it over JMX. So by default, almost all of the endpoints are enabled, but the exposure rules are different. So for the JMX, all of the endpoints that are enabled are exposed, whereas for the web, by default, as Madhura already explained, we only expose the health and info endpoints, but you can opt in to exposing more, customizing that as you need, as is appropriate for the security of your environment.
There's also a management.endpoints.web.exposure.exclude flag. So let's say you want to expose all the actuators over the web except for the beans actuator. So you can do that with this kind of combination where you say star is include or expose all my actuators except for the beans actuator. So these two properties together should give you a way to combine what you want to expose and not expose. So should we go ahead and...
Should we have a look at the kind of the HTTP list of all the endpoints that are enabled? So if you've got a Spring Boot application and you want to know the URIs that you can use to access a particular actuator, or you want to see which have been exposed, in Spring Boot 2.0 with no other dependencies on the class path. We had something like this in 1.5, but you had to have Spring Haterus on the class path. In Spring Boot 2.0, you don't need any additional dependencies, and you'll automatically get this. So if you go to /actuator, the default base path, whatever you've configured the base path to be for your actuator endpoints, will give you this list of all of the endpoints and the URIs that you can use to access them. And this is used by some additional tooling that integrates with Spring Boot. So for example, Cloud Foundry's integration for Spring Boot that we'll look at a little bit later uses this information to know which endpoints you've got available, which controls the extra information that appears in the Cloud Foundry Apps Manager dashboard. And there's also, how many of you have heard of Spring Boot Admin? A few. So there's a third-party project called Spring Boot Admin, open source project that provides like an administrative dashboard for Spring Boot applications. It will do some kind of service discovery and things as well, so it will, you can automatically set things up so that your applications will automatically register with the dashboard just by adding a small dependency to your app. And again, it uses this /actuators endpoint to get a list for all of the actuators that are enabled to control the information that it will display to you in its dashboard as well.
Right, so here's the list of all the available actuators from the actuator endpoint.
You can see one that's missing there is the shutdown endpoint.
Yep, and that's because the shutdown endpoint is disabled by default because it lets you shut your application down, and that's something we think you should really opt into if you know you've secured your shutdown endpoint properly. So let's go ahead and enable the shutdown endpoint. As Andy mentioned previously, each endpoint has an enabled and disabled flag. So to enable the shutdown endpoint, we can use management.endpoint.shutdown.enabled, and let's set it to true. If I rebuild, DevTools should pick up that property change. And we should be able to just hit the shutdown endpoint. Sorry. And that's going to be a post, so I need to put that here. So it gives you a message shutting down by. And
so it's not the kind of thing that you want someone to stumble across, hence why it's disabled by default.
The other thing that's new in Spring Boot 2.0 with the actuators is the health endpoint has some more configuration options. So by default, if you take a look at the response from the health endpoint,
this is what happens when someone runs the shutdown endpoint behind your back.
Right. I need to restart the application. Yeah. Thank you, Andy. So it did shut the application down. Right, so if I hit the health endpoint now, I can see that I just get back a status, which tells me that the application is up. But if you want some additional details about your health indicators, like if you have the data source health indicator and you want to know how that is doing, you can do that using the management.endpoint.health.showDetails flag. By default, it's never. Again, for security reasons, we want you to opt in to the details whenever you know you've secured the endpoints as you wish. So the options are never, which only shows you the status. There's the when authorized, which means that if there is an authenticated user and the user has the right roles, then show the details. For any other user or for an unauthenticated user, just show a status of up. And then always means it'll always show you the health details. So which one should we pick?
What should we, when authorized first?
Let's do that. So it's restarting the application. And
if we run that now with when authorized, it's still not giving us any details because we haven't authorized with the application. So that leads us on now to some changes that we've made to support the actuator that integrates with Spring Security. So we've tried to make it easier for you to customize the security of the actuators. So if we want to be able to authorize, we need to set up Spring Security, and we need to set up whether we're allowed, permission to access particular endpoints, whether you need to be authenticated, what role you need to be in, whether, we'll permit all access. So to do that, we can add the Spring Boot's security starter, as you normally would for if you wanted to use Spring Security with Spring Boot.
And I'm manually restarting the app this time because it's a class path change. DevTools won't be able to detect that.
And then securing the Actuators endpoints is really very similar, hopefully. Those of you familiar with Spring Security, it's very similar. The fact it's the actuator doesn't really make that much difference. You add a configuration class, you extend Spring Security's Web Security Configurer adapter.
And then you can override the HTTP security method, which will give you a bunch of configuration options using the Spring Security DSL. So http.authorizeRequests, and because we've now changed our security model a little bit in Spring Boot 2.0, we give you some convenience methods to secure your actuator endpoints. Because your actuator endpoints could be under any base path, you might have configured it to be under a different base path. You don't need to know what the base path is here when you're creating the security request matcher. You can use this class called Endpoint Request.
And there's a small gotcha here, so you can see there's 2 endpoint requests in this list. So a lot of you will probably already know in Spring Boot 2.0 and kind of in the whole release train that built on the top of Spring Framework 5, we introduced reactive support pretty much across the whole of Spring portfolio. So that came up from Framework into Boot, into Spring Security, into various other projects. And there are slightly different models for reactive security and for kind of the blocking servlet-based security. So there are 2 endpoint request classes in different packages, one if you're building a reactive app and one if you're building an app that's using that's servlet-based. So if you're using endpoint request, just take care to make sure that you get the one from the package that's appropriate to which web stack you're building on top of.
Right. So endpoint request has a few static methods. The 2, you can specify the endpoints that you want the request matcher for. So I'm going to say for the health endpoint, permit all requests. So permit unauthenticated requests to the health endpoint. We'll go back to that when authorized flag that we added for the details and show you how that works in combination with the permit all. Endpoint request to any endpoint, so any endpoint other than the health endpoint, because the health endpoint has its own request matcher, we can say that it has some role. So let's say it has the actuator role. And let's just use HTTP basic to secure that. So if we run the application again now and try to hit our health endpoint, let's try and hit it with a username and password. So because we have Spring Security on the class path, Spring Boot will give you a default user out of the box with a generated password and a username of user.
Just a slight aside, that randomly generated password is basically our attempt to make things a bit more secure out of the box so that you don't get left with admin or whatever and anyone can access your app. So by default, you'll get the username is constant, but the password is randomly generated each time your app starts. So hopefully that reduces the risk of you accidentally giving someone access to your app and also hopefully encourages you to set up some user detail storage that's more robust and more ready for a proper deployment.
Right, so we just hit the health endpoint here with a user and password. And as you can see that instead of just a status of up, we now get more additional health details from the health endpoint because we have the when authorized flag. If we were to hit the health endpoint with no user, it would still allow access because our security matcher says permit all requests to the health endpoint, but we don't see the additional details. So you can think of this to be useful if, let's say your application, you have a load balancer or some kind of monitoring system checking if your application is up, So you would just hit the health endpoint to get the 200 response, and let's say you get that the application is down, you can have a user actually log in to view additional details. Should we try and add Web Flux now?
Yeah, so well, if we remove the security from the picture, just to simplify a little bit so we don't have to update the security configuration to the reactive model. A change that we made in Spring Boot 2.0, so if we take a step back to 1.5, Spring Boot's Actuator was quite tightly coupled to Spring MVC, and we had requests from various people, because in the Spring Boot 1.x line, we also supported Jersey. For those of you who preferred the JAX-RS programming model, you could use Jersey rather than Spring MVC if you chose to do so. And there were a number of people who did, and they quite reasonably said, you know, can I use the Actuator on top of Jersey? And we always had to say no. If you can still use Jersey for your own endpoints, but if you want to use the Actuator, then you need to have Spring MVC in there as a dependency as well. And it wasn't the end of the world, but it did mean that you had some extra dependencies in your app, made it a little bit bigger, it used a bit more heap, none of which was ideal. So in Spring Boot 2.0, we knew that this problem was only going to get worse because Web Flux was getting added into the picture. And asking people to have a Spring MVC dependency when you're trying to use Web Flux wouldn't have worked, because Web Flux can run on top of Netty, which doesn't have any servlet support, so Spring MVC just wasn't an option in that environment. So that's really what prompted a lot of the changes in the Actuator in Spring Boot 2.0. We wanted it to work, to be a bit better detached from the web framework, so that we could run it on top of Web Flux and on top of Jersey, in addition to the existing Spring MVC support. So we can just switch the starter from starter web to starter Web Flux, start the app back up, and all of the code for all of the endpoints, and we'll look a little bit later at writing your own endpoints, none of that code has changed. So you just write your endpoints once, and they will run on top of Jersey or Web Flux or Spring MVC without you having to make any changes.
And as you can see, it started on Netty by default, because that's the default runtime that Spring Boot starts up on if it's a Web Flux application. And let's just make sure things work. So let's go ahead and hit our health endpoint, still up and running. So all you had to do was change the dependency in your POM, and the Actuator infrastructure, as Andy said, will just adapt to the web framework.
Okay, so we'll just kind of summarize now what Madhura, question.
Oh.
Sorry, can you change the health endpoints path or any of the endpoint paths so that just the one is in the root?
So the question was, can you change the health endpoints path or any individual endpoints path so that only one of them is under the root? And the answer is that you can't. You can change the path that each individual endpoint is mapped to. So say you didn't like /health and you wanted to change it to /foo. You could do that, but you can't just if the base path moves all of the endpoints or none of the endpoints. So you can move them all to the root or leave them all under something, but you can't just pluck one out and move it, expose it under the root mapping. You have to, it's an all or nothing. All right.
There's a question, but maybe we can take questions later because we have a lot to cover.
Okay. So what's new? Endpoints are, they're all under /actuator by default. You can move them should you wish to do so using the management.endpoints.web.basepath property. You can set that to / if you want to move everything to the root, or you can set it to admin or management or whatever might be appropriate for your environment and where you expect to find that sort of information. So as we discussed, there's kind of a difference between endpoints being enabled and being exposed, and if you want them to be accessible remotely, then you need to use the exposure properties. So there are two of those. So there's exposure.include and exposure.exclude. You can use a wildcard with include. You can also use a wildcard with exclude, although that's kind of pointless because it will exclude everything. The exclude property takes precedence over the include, as Madhura shows, so you can use include with a wildcard and then exclude just to switch a few of them back off as a more concise way of configuring that sort of arrangement. There are equivalent properties for Jmx. As we discussed, they have different defaults because we consider Jmx to be more secure out of the box because it's, you have to switch something on for Jmx to be remotely accessible. By default, for someone to connect via Jmx, they need to be able to run a process on the local machine. So you have bigger things to worry about than whether they can access your endpoints if someone's already managed to do that. All of the endpoints have enabled properties, and all of them are enabled by default other than the shutdown endpoint. So you can set management endpoint.shutdown.enabled. That one defaults to false. You can set that to true if you wish to enable the shutdown endpoint. And equally, if you wish to disable any of the other endpoints, then you can use management.endpoint, ID of the endpoint.enabled, and set it to false to switch them off. We looked at show details for the health endpoint, so you can control, you have some quite fine-grained control over who can and can't see the details of the health of your application. 3 possible values there: always, which means anyone who has access to the endpoint will see all of the details of your application's health. You can set it to never, which means that no one will see any details and all they'll get is status up or down. Or you can set it to when authorized. And then if you access the endpoint as an authenticated user and that user is in one of the required roles, then they'll see the details, otherwise they won't. By default, there are no roles that that user is required to be in. So by default, if you set it to when authorized, then any authenticated user is considered to be authorized. So you may want to, if you're using when authorized, you may also want to narrow that down to users that are in specific roles. We saw endpoint request for configuring the security of your endpoints. There's both servlet and reactive variants of endpoint request. And then lastly, we saw that you can use the actuator on top of Web Flux. Madhura demoed that. You can also run it on top of Jersey. And it's just a case of changing the dependency. So you'd swap out starter web for starter Jersey or starter web for starter Web Flux. And the actuator's infrastructure will take care of everything else for you. And that applies to the endpoints available out of the box and also any that you write yourselves, which you'll be learning how to do shortly. So we looked at some of the new endpoints. We showed a few of them in JConsole. And now we'd just like to kind of talk you through in a bit more detail some of the new endpoints and show you their capabilities.
Thanks, Andy. So one of the new endpoints in Spring Boot 2.0 is the scheduled task endpoint. And it was inspired from a proposal from one of the members of the Spring community. Unfortunately, I think they had submitted a pull request, but by the time we got the pull request, Andy and Stefan had already started changing the actuator infrastructure for 2.0. They were doing a complete rewrite, so we couldn't use their pull request. And but we did get inspired from their proposal, and it triggered some changes within Spring Framework itself to give us more information about the scheduled tasks running in your application. So if you hit the scheduled tasks actuator endpoint, the response looks somewhat like what you see on the screen. The runnable is the method that's going to be scheduled. And the expression is the times that it's going to run at for the cron jobs. We have similar configuration for fixed delay. Here you can see there's an initial delay and an interval. This kind of, the scheduled task actuator is useful if, let's say, you have a bunch of scheduled tasks in your application and things are not running as expected. You can go to this actuator and see if the configuration is right for your scheduled tasks. The next one is the sessions endpoint. And this is a contribution from another member of the community, Vedran Pavic. The sessions endpoint will be available when you have Spring Session on the class path. And as you can see, the response looks somewhat like this. So we can get the session for a particular user. You will see when the session was created, when it was last accessed, if it's expired or not. And you can also hit the delete method on the sessions endpoint to delete sessions for a particular user. Caches. So the caches endpoint, I believe, is new in Spring Boot 2.1. So it will be available once it's available in the milestones already if you want to give it a shot. Or if you want to go with Spring Boot 2.1 when it's released, you'll be able to use that once 2.1 is generally available. Again, a contribution from the community. So I think we're seeing a sort of pattern here. A lot of the new actuators are contributions from the community, and maybe that has something to do with the fact that the actuator infrastructure was rewritten so that it's easier to add custom actuators now than it was in the 1.x line.
And if you have written a custom endpoint or have an idea for an endpoint that you think would be useful, then we love getting pull requests or issues, making suggestions. So don't be shy about opening issues or pull requests in the Spring Boot tracker, because all of these have come from the community, and we'd love to get more if there's ones that you've written or that you think would be generally useful from your experience, because you know better than I do about in the whole boot team. You're running Spring Boot applications in production probably on a daily basis, so you have some insight that we don't. So we'd love to hear your suggestions for anything that any holes that we could plug in what the actuator offers.
And the caches endpoint, as the name suggests, it will give you a list of all the caches available in your application. The structure is we have the cache managers at the top level, which are keyed by ID, and under that we have the caches keyed by name. The target is the underlying native, the fully qualified name for the underlying native cache. You can also retrieve caches using the cache name. So for a single cache, if you want to just get a single cache, you can do that using the name of the cache. So here you'll just be able to see the target, the name, and the cache manager for that particular cache. The caches endpoint also lets you evict from caches, so you can delete from all the caches, or you can delete from a particular cache.
Another new endpoint that we've added is the integration graph endpoint. Again, another contribution from the community. So this is actually something that's built in. The integration graph thing is something that Spring Integration has had for a number of releases now, but we've now made it available via the actuator. So again, this is one like the session endpoint that appears automatically if you add Spring Integration to the class path, and you're using the actuator will automatically configure the integration graph endpoint for you. And it gives you information about all of the Spring Integration components that you're using and how they're wired together. So you can see here, here's a node within the graph. So in this case, it's a channel. It's the null channel. So you'll get a kind of an entry like that for every component. And then you also get information about the links in the graph. And this would allow something to then visualize the graph. So you get information about all the nodes in the graph and the links, and you can take all of that information and then basically plot the graph showing. So here we can see that, for example, node 2 is connected to node 3 in the graph. We've also made some changes to the health endpoint in Spring Boot 2.1. So as we've just seen, and I imagine a lot of you are already familiar with, you can hit /actuator/health and you'll get information about the status of your application. And also in the details, if you've configured things so that's exposed, you'll also get information broken down via each individual health indicator that's contributed information about the application's overall health. So here we can see we've got some information about the health of a database and also the health of a broker that the application is talking to. In Spring Boot 2.1, we allow you to drill down into the health. So rather than just querying /actuator/health, you can query /actuator/health/component, and you'll get this kind of more focused view on a particular part of your application's health. So here, we've just focused on the broker piece of the health response. So we can see, yeah, the brokers are up, and we still get the details. And the same rules apply in terms of whether or not those details are visible. It's done with the same overall configuration. And you can even drill down even further. So in this case, the broker, there were multiple instances that we were talking to. So you can focus right down onto the health of a particular aspect of your application, should you wish to do so. So now we'd just like to take a bit of time to show you some of the Cloud Foundry integration that the Actuator offers. And one of the cool things that's come out of the work that we've done to get the Actuator working on top of Web Flux and Jersey, in addition to Spring MVC, is that you can now also use the Cloud Foundry integration, irrespective of which web stack you're using. It will still integrate, and you'll get the kind of the enriched dashboard showing you more information about a Spring Boot app that Madhura is going to show us now.
So how many of you have heard of Apps Manager? OK, a few hands. Apps Manager is sort of, you can consider it the dashboard for your applications running on Cloud Foundry. And what you can see here, this is Apps Manager that's available on PWS, or Pivotal Web Services, which is Pivotal's hosted version of Cloud Foundry. And we added Actuator integration for Spring Boot applications for Apps Manager as part of Spring Boot 1.5 itself. But as Andy said, it's now also automatically available for the Web Flux applications and for Jersey applications. So let's take a look at how the dashboard is enhanced with some information from the Spring Boot actuators. So first of all, you can see that there's this tiny little Spring Boot logo next to the application name that tells you that this is a Spring Boot application. And where did Apps Manager get this information from? So we looked a little bit before at the /actuator endpoint, which gave you a list of all the actuators that were available in your application. And we have the same thing available for when your application is running on Cloud Foundry. We detect that the application is running on Cloud Foundry, and we offer the same actuator list at the Cloud Foundry application path. So if you see here, Apps Manager hits your application's route /Cloud Foundry application to get a list of all the actuators that are available in your application. And the reason why Apps Manager is not using the regular /actuator path and is using this different Cloud Foundry application path is because we wanted to secure the Cloud Foundry application path using OAuth tokens from the UAA. The UAA is Cloud Foundry's user authentication and authorization system. So we already have an inbuilt authentication mechanism built into the platform, and we just wanted to use the same for the actuators on Cloud Foundry.
It also means that your own application security, you deploy your app to Cloud Foundry, you don't need to worry about, am I going to allow, how do I allow Apps Manager to connect to the app? It kind of takes advantage of the fact that there's already this ability to authenticate and authorize because of the UAA within Cloud Foundry. So it's something that you can just kind of deploy, and you don't need to worry about there will be a secure connection established between the dashboard and your app without you having to perform any additional configuration.
Right. And apart from this Spring Boot logo here, there are a few other things that Apps Manager gets from the Actuator endpoints. The health for each instance of the application shows information from the health actuator. So this is along with the health details that the health actuator exposes. And the reason why we are showing the health details is because we have authorized that the user is authorized to view this application and its details on Cloud Foundry. This hello health indicator, I've just added a dummy health indicator which returns a status of up every time. You can add any custom health indicator that you want and map it to how you want to return the health of your application. In addition to that, let's look at the loggers endpoint. So this is an interesting one because you can actually change the runtime configuration of the loggers in your application through Apps Manager. And in the back end, this uses the loggers actuator. So if let's start tailing the logs. And if I filter by my application's loggers, I'm going to change the schedule logger to be debug. It was at info. And we should see some debug logging output from the schedule logger class. So we couldn't see this before because this was only logging at the info level, but we just dynamically changed this and you automatically start seeing the debug logging from that. So this is using the loggers actuator. You can use this actuator even outside of CF.
It's just making a post request, basically saying set the name. In fact, we cover the loggers endpoint in a bit more detail, but it's basically a post request, basically saying this logger set its level to debug or info or whatever. So you can do it yourself using curl, or you could build your own dashboard on top. It's just an HTTP post. So the question was, are these logs automatically available, or do you have to? So this is. I don't know what the retention policy for logs is on Cloud Foundry. Yeah, this would be some
configuration in Cloud Foundry. We are just, Apps Manager is pulling the console logs. Just real quick, another interesting feature that Apps Manager integrates with is Git information from the info endpoint. So let's say you deployed your application with some latest change that you made and it broke, and you want to see which commit broke your application. Apps Manager will link to the commit that was used to deploy the application, so you can go ahead and figure out what's going wrong. And this information comes from the info actuator endpoint. I'm not sure about other version control systems. Does the actuator?
It will give, so the question is it just for GitHub? The info endpoint captures information. It's basically captured at build time. It's metadata that's baked into your app, and it's just information about, this is the Git repository, this is the URL of the Git repository, this is the hash of the commit, and then Apps Manager is just surfacing that information in the dashboard. So as long as you provide a URL that's accessible, then it doesn't matter if it's on GitHub or anywhere. It's just the URL plus the hash of the commit. So the question was, do you need to do anything to enable this integration, or is it just enabled by default?
The Apps Manager integration? So for the Git information that was available, you have to add the Git plugin to your POM file. And whenever there's a git.properties file available at the root of your class path, that is exposed via the info endpoint, and then Apps Manager will be able to get it. You have to set an additional flag to say that the Git information mode is full, so that Apps Manager gets all the information. But apart from the Git information, the other actuators are integrated by default into Apps Manager, if you have the actuator dependency on your class path. Okay, I think that's pretty much what I wanted to show for the Apps Manager.
So just a quick summary of what we saw there. So the endpoints are all available under /Cloud Foundry application /actuator. And as we already explained, that's done for security reasons. That's a separate endpoint that's secured via the UAA, so that from your application's perspective, you don't need to worry about how Apps Manager is going to access the app. Is it going to be done securely? That's something that's switched on automatically. When Spring Boot starts up, it can detect that it's running in Cloud Foundry, and it can auto-configure that stuff for you. And then the UAA takes care of making sure that the apps manager has authenticated and is authorized to be able to access the endpoints without you having to configure anything. So yeah, valid UAA token. You can switch this off if you want. If you're not comfortable with this happening, you can set management.cloudfoundry.enable to false. And then you'll lose some of the, well, all of the Spring Boot specific stuff in the Apps Manager dashboard. So it's, it's a trade-off. Are you happy with this stuff happening or not? If you're not, you can switch it off. And again, this works on top of Jersey, Web Flux, or Spring MVC because of the fact that the actuator infrastructure is now web container agnostic. All right, well, another thing that we've worked on in Spring Boot 2.0 is to provide better API documentation for accessing the actuator's endpoints. We actually had, in Spring Boot 1.5, we had a Spring Boot Actuator docs module. How many of you were aware of the Spring Boot Actuator docs module? 3 people? That's pretty much as many downloads as it got as well. It unfortunately wasn't very discoverable. The idea was that you had this module, you added it to your app, and then your app would self-host API documentation for the actuator. But unfortunately, no one really knew about it, partly because if it's self-hosted, Google can't find it. So if you're searching on web, how do I do this with the actuator? It wasn't going to be indexed by any search engines. So we rethought that approach in Spring Boot 2.0. And so we now have, sitting alongside the reference documentation and the Java doc, we now have this separate set of documentation produced using Spring REST docs that describes all of the actuator endpoints for you. So there's detailed API information for accessing the actuator's endpoints over HTTP. And you can see here on the left-hand side in the table of contents, we have entries for all of the different endpoints. So there's every single endpoint that's available out of the box. There is detailed information about it. We give you information about example requests and response, detailed information about the structure of the requests. We have kind of JSON path things that says, at this point in the JSON document, you can expect to find this thing. So hopefully that should give you all of the information that you need to, make full use of all the actuator endpoints. And it'll tell you, we talked a little bit, for example, about being able to send a delete request to the cache's endpoint. So it'll give you information about all the different HTTP verbs that all the endpoints support to do different things with them. So posting to the logger's endpoint or a delete to the cache's endpoint. Tells you about all the path variables and everything that they support. So hopefully that will be more useful. And as I said, it just sits online alongside. It's a sibling of the reference documentation and the Java doc and things. So you go docs.spring.io /springboot/ the version, and then you'll find it sitting alongside the documentation for all the other components.
Right, and the last thing that we wanted to talk about, what's new in the actuators in Spring Boot 2.0 is metrics. I'm not going to spend a lot of time talking about metrics because I am not knowledgeable to do so. But I just wanted to mention that in Spring Boot 2.0, we've added support for a metrics instrumentation library called Micrometer. You've probably heard of it or seen talks related to Micrometer. It is a facade over multiple monitoring systems. So you can export your metrics to multiple backend systems such as Datadog, New Relic, Atlas, and there's a whole bunch of others, which you can find in the documentation. So one of the key differences between the Spring Boot 1.5 actuators and the support that we've got with Micrometer in Spring Boot 2 is that Micrometer gives you multi-dimensional metrics. So you can actually tag your metric with multiple tags and then use those tags to drill down to see what's going on in your application. So let's say you have tags such as the method for HTTP requests or the status code. You can go in and see how many post requests with status code of 200 or something like that. If you're interested in learning more about Micrometer and how it integrates with Spring Boot 2, you can view a recording of John's talk, because unfortunately John's talk was yesterday. But once the recording is available, John Schneider's talk on observability should cover Micrometer in much more detail.
All right, so now we'd like to shift kind of into the second half, or not quite half because we've got about 20 minutes left of the presentation to take you through how you can write your own endpoints. So we've talked about the infrastructure and the changes and the fact that you can now write the endpoints and they'll run on top of Spring MVC and Web Flux and Jersey, and we'd now like to kind of by example take you through some of the existing endpoints and show you the new endpoint programming model so that hopefully you'll leave here armed with the information you need to write your own endpoints. So the first one we'd like to look at here is the sessions endpoint. So again, it's a contribution from Vedran Pavic. So the first thing to notice here is the endpoint annotation. So we've referred to various endpoints throughout the presentation so far by their IDs. And when we were configuring them, enabling them, exposing them, excluding them, we were using those IDs. So when you want to write an endpoint, the first thing to do is to create a class, annotate it with endpoint, and give it an ID. And that ID has to be unique within your application, and you'll get a startup failure at runtime if you have multiple endpoints with the same ID. And the ID is used to map by default is how the URI for the endpoint is created. So we have the sessions ID here, and that goes down, maps straight down into the URL. So /actuator is the default base path, and then the ID is the part that's used to identify a particular endpoint within your application. So once you've got your basic endpoint set up, you need to be able to make it do things. And we call those operations on an endpoint. And there are different types of operations that you can perform. So this is a read operation taken from the sessions endpoint. So this is an operation that you're going to make a request to it, and the actuator is going to give you some information back. You're reading some information from the system. So you use the read operation, annotation, on a method on your endpoint class. And in this case, we're taking some input. So there's a username. So we're wanting to say, this is how the sessions endpoint provides an operation for getting a particular user's sessions. And it's going to return a sessions report for you. And the infrastructure will handle taking that response, that sessions report object, marshalling it to JSON and returning it to you as a JSON-based response. If you're familiar with Spring MVC controller or a Web Flux controller, it's very similar. You just return something and we worry about mapping it to JSON for you. So you can see here, because it's a read operation, it's mapped to HTTP GET. And then /actuator/sessions, and then the username comes into play. And that's automatically mapped to a query parameter. So you have, because your parameter to the method is called username, you automatically get a username query parameter on the URI. So here we're asking for all of Alice's sessions. An important part to note, we rely on the Java 8. In Java 8, you can compile your code with dash parameters, and that automatically means that all of the parameter names are baked into the bytecode, and then they're available to us at runtime. And that's how we know that your username parameter here was called username, and so that controls the name of the query parameter. And we'll automatically, if you're using our Spring Boot starter with Maven, or you're using the Gradle plugin, we'll automatically configure the Java compiler for your own app to enable dash parameters. But if you're not, that's something to be aware of. You'll want to compile, if you're writing your actuator endpoints, you'll want to compile them with the dash parameters option so that we can get that information out at runtime. So here's another read example. This one's slightly different. So the previous one was kind of using the username as kind of a search to say, well, I want everything that matches these criteria. So again, here we've got a read operation, a session descriptor. So here we're returning this time an individual session. So rather a report about lots of sessions. And we're returning some information about a single session. So here we're using, so the difference here is that the method parameter is annotated with selector, and that tells the actuator infrastructure this parameter should be used to select a specific thing. And here we want to select a session with a particular ID. So this gets mapped again to a GET request because it's a read operation. And this time the session ID gets mapped because it was annotated with selector. Rather than getting mapped into a query parameter, it's mapped into a path parameter in the URL. So this, we're now creating a URL for a specific resource rather than kind of something that's more like a search. Actually, if we go, another thing you can see here is that we're returning null in some cases. So there might not be any sessions with that particular ID. The endpoint infrastructure will automatically handle, if you return null, it will automatically map that to an HTTP 404. Whereas if you return an actual object that we're going to marshal to JSON, then that will automatically be an HTTP 200 OK response. All right, as Madhura also mentioned, you can use the session endpoint to delete things. So you can make a query to say, well, I want to get rid of this session. So for example, if someone wants to log out on all their devices and you had some kind of support infrastructure to set up to do that, you can use the session endpoint to help you. So you can delete an individual session using a delete operation. So again, it's very similar to a read operation. You just stick the delete operation annotation on your method. This one returns void. There's nothing really to return. It's just the delete happens. There's no information to come back. That will get automatically mapped to an HTTP 204 response. So that's kind of, it's basically saying successful, but there's no content. So it's an indication in the status code that the response won't have any body. And again, we're using a selector here to identify a specific session that we want to delete. And this time, the delete operation, as you might imagine, hopefully it's intuitive at this point, the delete operation gets mapped to the HTTP delete verb. And the session ID, again, in the same way as it did for the GET request, because it's annotated with selector, it comes down into a path parameter within the URL. Switching now to the loggers endpoint. The loggers endpoint has a write operation. So this is the endpoint that was used when Madhura changed the log level in the Apps Manager demo. So again, very similar, endpoint annotation ID. This time it's the loggers endpoint. We have a write operation this time. So this is how you pass information into the actuator and ask it to make a change for you. We're returning void again, so that'll get mapped to an HTTP 204, assuming the request is successful. Here we're using the selector again. So we're saying we want to select a specific logger, and that's the logger, the level of which we want to configure. And we're also passing in the log level. So this is basically saying for a particular logger, set its logging level to whatever is passed in. And the nullable annotation here is saying to the actuator endpoint infrastructure that this argument is optional. You don't have to pass it in. If you're familiar with how loggers generally work, they're hierarchical and they inherit their level from their parent logger. So if you set like a level on com.example and then you have com.example.alpha that hasn't got a level configured on it, it will automatically inherit that from its parent, from the com.example logger. So there may be a case where you've set a very specific logging level for kind of a low-down logger, and you want to clear that and just ask it to inherit the level that's been configured on one of its ancestors. In that case, you just wouldn't pass in a level. And that would just clear it out and allow it to inherit from one of its ancestors again. And that's what the use of the nullable annotation lets you do. So we can see this, the write operation gets mapped to an HTTP post request. And the name of the logger comes down into the URI. And then we also need to be able to, so how do we pass the information about the level? And this is automatically mapped into the JSON body. So you send a post request with a body with configured level. And in this case, we're setting it to debug. And again, that configured level, that's the key in the JSON payload, is named configured level because that's what the method parameter was called. And again, that's relying on the dash parameters switch and that information being available in the bytecode. So that's kind of the basics of the programming model, but there are also some things that we've added to let you go beyond that. When that doesn't quite give you what you need, if you have more advanced needs, then you can do so. And Madhura will take us through that now.
Thank you, Andy. So in addition to the endpoint annotation that's been added in Spring Boot 2, we've also added some technology-specific annotations because you might want to change the behavior of your actuator endpoints for a particular technology. So you might want the actuator to do something over HTTP, whereas it might do something else over JMX. Let's take the health endpoint, for example. So we have the health endpoint web extension. And that's using the @endpoint web extension annotation. And the endpoint attribute there is the target endpoint that you want to extend. And the reason we're using this extension for the health endpoint is because when you get the overall health of your application, so let's say you get status up from the health endpoint, we want to map that up to an HTTP status code. So up will map to HTTP 200 by default, down maps to, I think, 503 service unavailable by default. And that's the kind of behavior that we've put into the web extension for the health endpoint. One thing that you see here is that the return type is a web endpoint response. And if you're familiar with Spring MVC, this is similar to the response entity class, but the reason why we're not using response entity is because this is web infrastructure agnostic. We didn't want to tie ourselves to a particular web framework, and which is why we added this custom return type. Another thing you'll notice is security context. So a little bit before in the talk, we saw how the health endpoint was returning details based on whether the user was authenticated or authorized. And we can do that using the security context interface, which can give you the principal that's present in the authentication and whether that user is in the role that you wanted to specify for the health details. Again, we're using the security context. We're not tying ourselves to HTTP servlet request because in the MVC in the servlet world, you can get whether user is in a role or the principal from the HTTP servlet request, but we wanted this to work for Web Flux too, so we've added this web infrastructure agnostic interface. The last thing that we wanted to mention in this talk is something that is a little bit of an edge case, and in most cases, the endpoint infrastructure that is available to you should work. But let's say you were using Spring Boot 1.5 actuator customization to write your own custom actuators. And because the Spring Boot 1.5 actuators were tied to Spring MVC, there were a few things that you could do in Spring Boot 1.5, which we wanted to continue allowing in Spring Boot 2. And one such use case is the servlet endpoint annotation. So let's say you have a third-party servlet that you wanted to expose as an actuator endpoint. You can do that now using the @servlet endpoint annotation. And the advantage of using the @servlet endpoint annotation is that when you change the base path of your actuators, this endpoint will also move under that base path. The security model that we saw initially with endpoint request will also apply to the servlet endpoints that you expose using @servlet endpoint. You just need to use this annotation and a little helper method which tells the actuator infrastructure which servlet you want to expose as an endpoint.
You also get properties for enabling the endpoint, so and the exposure include and exclude stuff. So it basically makes a servlet appear as if it was just a normal endpoint. So you get all of the configuration options that we've seen.
And in addition to that, we have the controller endpoint and the REST controller endpoint. These two annotations are tied to Spring MVC and Spring Web Flux, so you won't be able to use these if you have Jersey or over JMX. And in Spring Boot 1.5, you could write MVC actuator endpoint adapters to sort of get the full capabilities of Spring MVC in your actuator endpoint. So you could do things like content negotiation within your actuator endpoints. And to allow you to do that in Spring Boot 2, we've provided controller endpoint and REST controller endpoint, but this is still at the expense of portability. So once you start using these annotations for your custom actuators, you will be tied to that particular web framework, and other applications, let's say over Jersey, will not be able to use those endpoints. So our hope is that the endpoint infrastructure that we've provided using the @endpoint annotation and the technology-specific extensions that should work in most cases, and you should only use this for if you want a way out or you want to do something special in your actuator endpoints. And I think with that, that's all we've got for today.
Yeah. Thank you very much, everyone.
Thank you.